Before we go on to actually do our first hypothesis test, let's just go back to section 7.1 and to go over the different types of errors that are possible when we make a hypothesis test. So in general, there are two different decisions we will ultimately make. We will either choose to reject the null hypothesis or we will fail to reject the null hypothesis. In terms of the null hypothesis itself, there's two possibilities for the truth value of it. The null hypothesis could be true or it could be false. So two choices for the decision, two choices for the truth value, which give us a total of four different possibilities. For example, in the event that the null hypothesis is true, we would not want to reject it and claim otherwise, to claim that it's false in that situation. If we did, then that would be what's called a type 1 error. So the type 1 error is rejecting the null hypothesis when the null hypothesis is indeed true. Alternatively, if the null hypothesis is false, then the hope would be that we would show it's false by rejecting it, and in that situation, that would be the correct decision. So when we actually reject the null hypothesis when it's false, we have made the correct decision. When the null hypothesis is true, we would hope to not reject it. That would be the correct decision. So we do not want to reject the null hypothesis when it is true. That would be the correct decision. However, if the null hypothesis is actually false, but we fail to reject it and show that it's false, then that too is an error, and that's referred to as the type 2 error. So again, there's four possibilities altogether. If the null hypothesis is false, we would want to reject it. If the null hypothesis is true, then we would not want to reject it. When we reject a true null hypothesis, that's what's referred to as a type 1 error. When we fail to reject a false null hypothesis, that's referred to as a type 2 error. One of the other things we want to highlight, and this will come up in a moment, is what's referred to as the different type of tests. We said there's three different tests altogether. The first test would be the mean is greater than or equal to k, with the null, and its corresponding alternative would be the mean is less than k. When we talk about the tailness of a test, the tailness of a test is determined by the alternative hypothesis. For example, when the alternative is that the mean is less than something, think less than as in left on like a number line. This would be a left-tailed test. On the other hand, if the alternative hypothesis for the middle one was that the mean is greater than a value, we think of greater than as being to the right. So this would be your right-tailed test. And if the mean is not equal to a number, that could happen one of two ways. Either the mean is really less or the mean could be greater than. This would be the two-tailed test. So if you're looking for the tailness of a hypothesis test, it's all about looking at the alternative. Less than is a left-tailed test. Greater than is a right-tailed test. And not equal to would be a two-tailed test. Let's go ahead and do our first hypothesis test. Suppose a tobacco executive industry claims that smokers need less sleep than the general public, which needs an average of 7.7 hours of sleep. So they're claiming that smokers need less than 7.7 hours of sleep per night. To test their claim, we're going to gather a sample of 50 smokers, and our sample of 50 smokers finds that they require only 7.5 hours of sleep with the standard deviation of 0.5. Let's test this person's claim with a 5% level of significance. So we read it through, a lot of information here. What you want to do in the very beginning is start to go ahead and slowly start to put all of this together. And let's follow the series of steps. First thing we need to do is set up our null and alternative hypothesis. In the problem, they're claiming that smokers need an average less than 7.7 hours of sleep per night. Mean less than, that's going to be an alternative hypothesis, which in this case is going to be the claim, because that's what was told to us. So that's the alternative. The null hypothesis will be the complement of that, which would be that the mean is greater than or equal to 7.7. The next thing we would want to do is state what the confidence level of significance is. That's alpha. Here it's 5%, which is 0.05. This will be the number we compare against p at the very end to make our decision. And now we need to find that value for p. For this particular problem, because we have a large sample size, 30 or more, we can find p via a z-score. And the way that we're going to do that in the calculator is with a brand new command called a z-test. The z-test is found under the stat menu. Go to the right to where it says tests. We've already used this menu below when we were calculating things like z-intervals, t-intervals, and one-prop z-intervals in the previous section. What we want to do is run a z-test for this. We have a couple different options in terms of the input style. We weren't given the sleep times of each of those 50 smokers. What we were given instead was the summary statistics. So that's going to be our stats. In here, they're going to ask eventually for two different means. There's mu sub 0 and x bar. The mu sub 0, this is always the same number that appears in our hypotheses. So if you look at the null and the alternative, they use the value 7.7. So that's what's going to go here. The standard deviation was told to us. If we go back in the problem, they said with a standard deviation of 0.5. X bar is the sample mean. The executive said that for the sample of size 50, they only require 7.5. So that's 7.5. Our sample size was 50. And now the last thing, which is very, very important, is we have to choose the appropriate tailed test. This part here will always be determined by the alternative hypothesis. Because the alternative hypothesis was mu is less than, this was a left-tailed test. So we have to go over and select the left-tailed test, which is this one right here. I need to move the cursor over so that it's highlighted, and then hit enter to make sure that it's selected and set. Once we've done that, we can go ahead and hit calculate. And the thing that's really nice about this, the calculator, either the 83 or the 84, is they will give us exactly the p-value that we need to complete our hypothesis test. So p is going to be 0.002. On the homework, they're also going to ask you for the z-test statistic. That z-test statistic will also be provided to us. It's negative 2.83. Okay? Again, we're not going to focus on this. We're not doing critical regions or the critical z-stat. We are going to focus on the p-value approach. So this is what we need to use. Now that we have p, it's 0.002. We can compare it to alpha, and we see that because p is less than alpha, going back to the previous section, whenever p is less than alpha, the decision will be to reject the null hypothesis. So we will be rejecting the null hypothesis. So after all of that, it's now finally time to go ahead and summarize what we've just found. Because we rejected the null hypothesis, our conclusion statement will begin with the form, there is enough evidence, and this is at the 5% level of significance. So again, anytime it's reject the null, it's always there is enough evidence at the significance level to, and now we have to go back to see which of the hypotheses was the claim. Whenever the claim is the alternative hypothesis, the second part will be to support the claim. So whenever the alternative hypothesis is the claim, it'll be of the form to support the claim. So putting it all together, there is enough evidence at the 5% level of significance to support the claim that smokers do indeed need less sleep than the average population, less than 7.7 hours of sleep. So through this hypothesis testing, we were able to check and fact check that individual, and it does look like they are indeed telling the truth. Let's take a look at another example. A cereal manufacturer claims the mean sodium content of its company's cereal is no more than 230 milligrams per serving. To test this claim, we gather 52 servings and find that the mean sodium content of the sample is 232 milligrams with a standard deviation of 10 milligrams. Test the manufacturer's claim at the alpha equals 0.025 level. We're going to do this the same way as we did the last one. It's another hypothesis testing question. Let's begin by identifying the null and the alternative hypothesis. In the problem, they make the statement that the sodium content, the mean sodium content mu, is no more than 230. No more than means less than or equal to, and because of that equal to part, that means that that is going to be the null hypothesis. So the null hypothesis is the mean is less than or equal to 230, and that's our claim. The complement of less than or equal to is going to be greater than, so the alternative hypothesis is that the mean is greater than 230. The level at which we're going to do our test, this level of significance is alpha equals 0.025. And once again, because we have a sufficiently large sample size here, we have a size of 52, which is more than 30, we can once again use the z-test or a z-statistic to compute our p-value. Again, this menu is found under Stat. We go over to Tests, and right now we're using option 1, which is the z-test. We didn't have the values for all 52 boxes of cereal. We had the summary statistics, so I'd work off of the Stats ribbon again. If they actually gave us all of that raw data, then what you would want to do is hit Stat, Edit, put it under list L1, and then you'd be able to work off of the Data tab. First thing we need is the mu sub 0 value. This is the same value that's going to be stated in the hypotheses. In this case, it's 230. The standard deviation, they told us, was 10, with a standard deviation of 10 milligrams. The mean of the sample was 232. Our sample size was 52. And now the last thing we need to do is pick the appropriate tail test. Because our alternative hypothesis was greater than, that's a right tail test. I need to go over to the right tail test option and hit enter. And then we're going to go ahead and calculate this. Once again, if you want the z-test value, it's on there. We're not going to use it. You will have to enter it on occasion and on a few of the problems on MyStatLab. But what we're really after is this p-value here. The p-value is 0.075. And that's the number we need to compare against the level of significance alpha. P is 0.075. Alpha is 0.025. So we're in the situation where P is greater than alpha. And remember, anytime P is greater than alpha, the decision is to fail to reject the null hypothesis. So that's going to be our decision, fail to reject the null. From there, we're now going to go ahead and summarize things. Because the decision was fail to reject the null, our final sentence will begin with, there is insufficient evidence. So anytime you fail to reject the null, it always begins with, there is insufficient evidence at the 2.5% level of significance. And now to finish the sentence, we have to see which one of the hypotheses the claim was. Here, the claim was H sub 0. Anytime the claim is H sub 0, the second half of the sentence will be to reject the claim. To reject the claim. So there isn't enough evidence at the 2.5% level of significance to reject the claim that the mean sodium content is no more than 230 milligrams.